I start the subject, I would like to invite you all to visit my country, that is India. It's a beautiful country, lots of people, lots of noise, lots of events. It is one of the oldest living civilization on the globe. And with our new leadership in the seat, new Prime Minister, within a year we are the fastest developing country, fastest growing economy in the world, and it is going to be a land of lots of opportunities. So I would like you to visit my country at least once in a life. To start with the subject, these are my point, and basically this exercise came to my mind because of I received one question from a while a presentation or while a lecture in front of architectural school, that while I was talking about the reflections, and the question from a student was that can you demonstrate this practically. So I tried it, and in many parts of the world I have also seen, in especially not in Europe, but more focus is given on absorption, and this is what we all know, especially about the reflections. Lateral reflections increase the source width of musical, and ceiling reflections, early reflections improve the speech clarity. Michael Barron has given lots of explanation and lots of papers on this. And the point was that can we experiment it practically. So I tried to experiment it with the computer simulation model and actual measurement of one of the auditorium. This was auditorium I designed some 6-7 years back. It is for one of the schools in our part of the world is more or less government funded. They are having some less budgets, some less resources, and basically designed for speech. That was the design reverberation time with my calculations, and this is actual measured values. And what we tried is we put the screen, these ceiling reflections, to mask the ceiling reflections, we put the screen of half of the auditorium, and further measurements were taken. So this is the SPL level, and we can find that by reducing the reflections or by neglecting the reflections, the SPL is not that much affected. That means what results we are getting in the next slide, that is not because of the gap of signal to noise ratio. The signal to noise ratio is constant, and these are the results. This is without the air conditioning on, that is the noise criterion NC30. If you find that space transmission index STI figures, side A is with reflections and side B is without reflections, and the difference is quite noticeable. And even in actual measured values, the same almost similar results are getting. These are the locations, these are the seats where the measurements are taken. This is with some additional noise. Still the reflection difference is there significantly, and it is increased. So once again we can say these reflections are definitely very helpful, but unfortunately in most of the cases or most of the designs that I have seen in our part, that reflections are missing in design. More focus is given on the absorption, maybe because absorption calculations are simple, absorption data is widely available or widely forced by different means. It is more discussed, maybe because of in architectural colleges and schools they discuss and they taught more about the absorption calculations. Maybe it is difficult to merge the reflections with the demand of architects' interior decoration schemes, and maybe somewhat more dependent on electronic reinforcement. And my point here is that the difference of cost in absorbing material and in reflecting material is significant. If we try to use more absorbing and to get that speech clarity result, if we could balance it out with a reflection, we probably could save the cost of construction in acoustical absorbing materials. And that is what needed in the developing countries, where the cost of the project, we have got lots of schools with lots of classrooms, and to control that cost, so we can achieve good results, good acoustical environment with this balance. That was my point. Thank you.